Okay, this is the Spring 21 exam for Physics 102, exam 2. First, let's look at this capacitor circuit. And the first step that you want to do is just to redraw this circuit so it's in a more typical fashion. So here's my battery, and I'm going to come up off the positive side of the battery and come up to this point. I want you to notice that you have three different branches here. So I have at that junction, I'm breaking into three different parts. And on the far right, I have a 6 and a 3 microfarad capacitor 6 and 3 microfarad, and then I have a 1 microfarad, and then I have a 3 microfarad. And then these all come back together. So these three branches, they all end and they come back together right here. Because you see, since there aren't any capacitors, say like right here, right here, right here, that since there aren't any there, I can just combine all these different junctions into one point, and that point comes back to right here. And then as I come back through here, I have another capacitor. That's that 2 microfarad capacitor. And then I go back to my battery, and that's 12 volts. Now, I want to know what is the equivalent. So let's go ahead and find that. Now, first of all, I have this 6 and 3 in series, 1 over 1 over 6 plus 1 over 3. That's equal to 2. Isn't that right? 3, 6, but yeah. 1, 6 plus 2, 6, 3, 6. 2, 6 is 3, 6. That's 1 over a half is 2. And then I combine that 2 microfarad with the 3 and the 1. 2 plus 1 plus 3, that's 6, right? So I have a 6 microfarad. And let's see, this is actually supposed to be 3 microfarad. I'll change it in the on the exam. So I have that 3 microfarad right here. So that leaves me with a 6 microfarad and a 3 microfarad on a 12 volt battery. And then, of course, the combination of those two is going to be 2 microfarads. So 12 volts, 2 microfarads, and now I begin stepping backwards. So the first answer is the equivalent capacitance is 2 microfarads. And now let's step back, and I really need to find the charge and our voltage on all of these, but I'm looking for them on C2 and on C3. Okay, so let's change colors. We'll start stepping backwards. I know that I have 24 microcoulombs on this. Q is equal to CV. That's 2 times 12 is 24. That 24 microcoulombs is also here and here because capacitors in series have the same charge and they have the same charge as their equivalent capacitor. Then I can also find the voltages. So V is equal to Q divided by C. That's 24 over 3 or 8 volts and 24 divided by 6 or 4 volts. And then I double check 8 plus 4 is equal to 12. Up here, I have 8 volts on this capacitor. I have 4 volts on this one, 4 volts on this one, and I have 4 volts split across these two capacitors. So I need to figure out how is that 4 volt split across those two capacitors. Well, I know that these are a 2 microfarad equivalent capacitance with 4 volts. That means that they have 8 microcoulombs on them. Q equals C times V gives us 8 microcoulombs. So I have 8 microcoulombs here, 8 microcoulombs here. Then I can find out what is the voltage by saying, well, 8 microcoulombs divided by 6, that is 4/3 volts, and then 8 divided by 3 is 8/3 volts. So that gives me the charge on C3, that's 4/3 volts, and then I also needed that's the voltage on C3, and then I also need the charge on C2, and C2 is this 1 microfarad capacitor right here that has 4 volts, and so 1 times 4 is 4 microcoulombs. So that's the answer for the capacitor circuit. Now let's look at this one. What is the voltage across R3 and what is the current through R5? So the first thing is going to be to find the equivalent capacitance. I'll combine these two. 2 plus 4 is 6 ohms. And then I'll combine these two. 1 over a half plus a half, that's 1 ohm. And then I'll go and combine these two as well. I have 6 and 3 in parallel. So I have 1 over 6 plus 1 over 3, that's 2 ohms. So my near final circuit is going to look like this. I have a 1 ohm resistor and a 2 ohm resistor. 1 ohm, 2 ohm. So the final equivalent resistance is 3 ohms. So that's 12 volts, 3 ohms. And then I want to know the voltage across R3. Well, let's go ahead and find the total current. So I have a current of 4 amps right here. I is equal to V over R. That's 12 over 3, or 4 amps. 12 volts over 3 ohms. That's 4 amps. So this 4 amps, let's change colors again. This 4 amps is going through this circuit because resistors in series have the same current, and they have the same current as their equivalent resistance. So that 4 amps is going here, and it's going here. Now I can calculate then what is the voltage. I times R, 4 times 1 is 4 volts, and then 4 times 2 is 8 volts. So I'm almost there because I have 4 volts here and 4 volts here. Now remember, this is the equivalent resistance, and capacitors in parallel had the same voltage, and they had the same voltage as their equivalent resistor. So whatever I have here on this resistor, I will also have on these 2 resistors because they're in parallel. So I have 4 volts and 4 volts. And then over here I have 8 volts on this 2 ohm. That means I have 8 volts here, and then I also have 8 volts here. So my 8 volts is across R3 and R4. Notice I have 6 ohms here, so 8 volts divided by 6 ohms will give me I. That is 4/3 of an amp. And 4/3 of an amp here will give me a voltage of 8/3 volts and 16/3 volts. I might change these numbers, I'm not sure, I'll see. But anyway, that is my voltage there for R3 is 8/3 volts. If I change it, I'll just change it in a minor way. And then what is the current through R5? Well, I know the voltage across here. So my current, I5, is V over R, 8 volts over 3 ohms, or 8/3 amps. Okay, I might change some of these numbers just to try to get rid of some of these fractions. We'll see. Now, calculate the currents in this circuit, give the magnitude, and circle the appropriate direction. So I want to know I1, I2, and I3. I'm going to pick some equations here. I'm going to do the big loop, and I'm going to do the bottom loop. First, I'm going to pick some directions for my currents. I'll pick I2 and I3 to the right. No reason I'm doing that. I'm just picking them randomly. So pick those directions for I1, I2, and I3. And now I'm going to write my equation. Let's do the bottom loop first. I'm going to start here and go in this direction. So this is the bottom. I have 2 volts coming up here to the 6 ohm resistor. I'm going against the current, so it's plus 6 I2 and then plus 8 equals 0. That's the bottom. I'm going to go ahead and solve this for I2. I2 is negative 10 divided by 6, or negative 5/3. Now let's do the big loop. The big loop is, I'll start here and go in this direction. That is going to be 2 plus 4 minus 2I1 is equal to 0. And I'm going to go ahead and solve this for I1. I1 then is equal to 6 divided by 2, or 3 amps. I can go and write some of these. I1 then is 3 amps. It came out positive. That means that I chose that direction for I1 correctly, so it's left. I2 is minus 5/3, so the magnitude is 5/3 of an amp, but it came out negative for I2. That means I chose it to the right. That means it's actually to the left. And now to find I3, I'm going to need to pick a junction. And that junction has I1 going in, and I2 and I3 going out. So I'm looking for I3. It's going to be I1 minus I2. That's going to be 3 amps minus negative 5/3. That's 3 amps. I'm going to write this as 9/3 plus 5/3 equals 14/3 amp. So this is going to be 14/3, and then I3 I chose to the right. Looks like that is correct. Those are the free response questions. As I said, there might be some changes in numbers on that number too. Let's do the multiple choice. Consider these two capacitors. If the voltage across the 3 microfarad capacitor is 12 volts, what is the voltage across the 6 microfarad capacitor? I don't know what battery is providing this, but I can do this because I know the big capacitor is going to have a small voltage. Because remember, Q is equal to CV. If my capacitance is big, that means my voltage is small, because capacitors in series have the same charge. That's going to be a constant value. So it's going to have the smaller, and it's going to be smaller by a factor of 2, because this capacitance is twice this capacitance. So a voltage that is smaller by a factor of 2 is 6 volts. 1 is B. What is the charge on C1? So I'm just going to draw this. I have a 2 microfarad. And that 1 and 1 is 1 plus 1. That's 2 microfarads. I want to know the charge on this guy right here. Well, if I have 12 volts here, since these two are identical, I can say that they have equal voltages that add up to equal to 12. So that's going to be 6 volts each. That means that I'm going to have 12 microcoulombs on that one. So the answer is D. So the circuit, all three capacitors are identical. What is the voltage across C1? So this is similar. I'm going to have C1 and then 2C right here. And this is 12 volts. I'm going to have twice the voltage on C1. That means I'll have 8 volts and half the voltage on that 2C. So I'll have 8 volts, 4 volts, and 4 volts. 8. A is the right answer for number 3. Capacitors in series have the same charge. A 10 ohm resistor has a constant current. 1200 coulombs flow in 4 minutes. What is the voltage? So I know V is equal to I times R. So I need to figure out what is I. That's going to be Q divided by T. That's 1200 coulombs times 4 minutes, but I want to convert that into seconds. 4 times 60 is 240 seconds. So that's over 240 seconds. I can get rid of that. 120 over 20, 24, that's 5 amps. So I have a current of 5 amps, and I want to know the voltage, so it's going to be 5 amps times the resistance, which is 10 ohms. That's going to be 50 volts. Which of these statements is necessarily true? Voltmeters are hooked up in series. Ammeters measure voltage. Nope. The resistance of an ammeter is big. No, the resistance of an ammeter is small. The voltage across an ammeter is small. Now, the resistance of an ammeter is small. Really, really small, in fact. It's like basically just a wire. And since V is equal to IR, if R is really small, that means that the voltage will be small. So 4 is correct. Battery has an ideal electromotive force of 12 and an internal resistance of 2. You measure the terminal voltage to be 8 volts. What is the current? So the terminal voltage is equal to the EMF minus IR. This is really just an application of the loop rule. 8 is equal to 12 minus I times 2. And so solving that for I gives me 2 amps. C is 7. Resistor has a voltage of 12 volts and a current of 3 amps. When the voltage is 20 volts, the current is 5 amps. Is this an ohmic device? Well, let's calculate the resistance in both cases. That's V over I. 12 divided by 3 is equal to 4 ohms. And if the resistance stays the same, then we know that it is an ohmic device. Or if you can still define it by Ohm's law. 20 divided by 5, that's also 4 ohms. So, yep, this is an ohmic device. A 40-watt light bulb and a 20-watt light bulb are in power supply. In parallel with power supply of 120 volts, what current flows through the 40 watt? Well, if it's in parallel, that means that it's going to have a voltage that's equal to the power supply. And then our power is 40 watts. I want to know the current. That's P divided by V. That's 40 over 120. 4 over 12 or 1 over 3 or 1.33. A is 9. Which resistor produces the most power here? Well, power is V squared over R, or I could think of it as I squared R. Regardless, all of these resistors are the same, so I'm looking with the one with the biggest voltage or the biggest resistance. You know, let's talk about current. So if I have current that comes here, that current is going to split up into either place. So it's going to have the same current, I. But over here, that current comes back together and then it splits up again. So up top, I get a really small current, but down in the bottom, I get a bigger current because it's a path of lower resistance. So R5 will have the biggest current of all four of these, and it will also have the biggest power, produce the most power. Ooh, I like this question. Rank these four bulbs from bright to least bright. And the four bulbs that we're considering is A, B, C, and D. And again, we're really thinking about what is the voltage. And the voltage, since P is equal to V squared over R, will tell us what is the power. It's related to the power. So this is going to have V over 2, right? Because those two light bulbs will split it up. Notice this has 2V, so it's going to be 2V divided by 3. So that bulb B is going to have 2/3 of V. D is going to have 2V, and then C is going to have 2V divided by 2, or V. So my biggest bulb is going to be D. Well, that doesn't help me much because they're all the same. And then what's the next one? So I have 2V here. Looks like C is the next one. That C is smaller than D, so I can get rid of some of these. Whoop, I can get rid of them all. And then A and B follow. Wait, no, I'm sorry. No, I made a mistake there. Let me go back here. Because, yeah, I changed this, and the answer actually is DC, D, C, and then B is the next biggest, because 2/3 V is bigger than V over 2. So it should be DCBA. I think I'd change that. I might be working on an old version, so that's okay. But the answer is DCBA. Your options might be changed on that. All right, current of 0.6 amps flows through a wire of length 0.5 meters and an area given there. There's the potential. What is the resistivity? Select the material. So first I have to find out what is R. That's V over I. V is 1.2 divided by 0.6. That's equal to 2 ohms. So I have a resistance of 2 ohms. And then I take my resistance equation, which is R equals rho L over A, and solve for rho, and I can calculate rho. That's going to be 2 ohms. The area, which is given here, 6 times 10 to the minus 9, divided by the length, which is 0.5 meters, and then I find that's 2.4 times 10 to the minus 8. Oops. Oh, what's that? Ohm meters. That's rho. 2.4 should be 2.4, which of course is gold, so C is the right answer. Two pieces of copper wire are the same length. The diameter of wire A is twice that of wire B. So here's wire A. Here's wire B. So I already know that the resistance of wire A is going to be smaller than the resistance of wire B, just because it has a bigger cross-sectional area. And remember, R is equal to rho L over A. But the cross-sectional area is actually smaller by a factor of 4, because remember, area is pi r squared. So if I double my radius, I quadruple my area, my cross-sectional area. So if that's quadrupled, that means that C is the right answer. What happens to the voltage if you remove R2? So if I get rid of this resistor, what happens is that the equivalent resistance of this part goes up because I'm removing that resistor. And then if that equivalent resistance goes up, then that means that the, I'm looking for R1, then that means that the voltage of this part also goes up. So V1 will increase. So 14 is A. So to this circuit, which of these equations is or are correct? All right, let's just see. I1 equals I2 plus I3. I have I1 coming in, I2 coming in, and I3 going in. So that's not right. It should be I1 plus I2 plus I3 equals 0. And then I have 4 minus 2I1. I'm starting here. 4 minus 2I1 minus 8. So far, so good. Plus 6I2 equals 0. That looks right. Then I have 4I1. I don't even have a 4 ohm resistor. In fact, you see I was doing it right here, 4I1 minus 2I1, but that's not correct because that I1 shouldn't be there, plus 2I3. If I get rid of the I3, if I get rid of those things, it's correct, but as it's written, it's not correct. And then I have 8 plus 2 minus 6I2. That's right here, and I'm going in this direction, so it's positive 8 plus 2 minus 6I2, and that's equal to 0. So D is the right answer. So B and D is the right answer. 15 is C. Oh boy, what is I? So I'm looking for this current. Look at this junction. I have I coming out. If I can figure out what this current is, then I can figure out what I is. Well, look, I have 12 amps coming in here and 4 amps coming out there. That means that that current is going to be 8 amps. And then if I have 8 amps there, this is 5 amps. That means this must be 3 amps. So B is the right answer. So the circuit, what is the current? I have to write the loop rule for this. So I'm going to write it in this direction. I'm going to assume that my current is in this direction too. So I get 12 minus I, minus 1 times I, plus 6 minus 2 times I equals 0. This is a nice simple application of the loop rule. I equals 6 amps. Oops, sorry. What is the voltage across the battery? So let's redraw this. I'm going to find the equivalent of these two parallel resistors. That's 3 and 6 in parallel is 2 ohms. 1 ohm, if I have 6 volts here, if I have 6 volts here, then I must have twice that, or 12 volts here. That means this must be 18. Which of these is for resistors in series? So they must have the same current? Yes. Must have the same voltage? No. As you add, the total current increases. In fact, the total current would decrease because the resistance goes up. As you add resistors in series, the voltage across the other resistors decreases. Yes, 1 and 4. And then who's my favorite student? These are all amazing students, but right now you're my favorite student because I want you to do well in this course.